Hi guys, so this is the last problem solving concept with quadratics. It is about maximizing revenue. So we have two examples on it. It's the last page of your note. So the first thing we need to do is just establish to make sure you understand what revenue is. So revenue is the amount of money you take in or you earn, right? So before your costs, okay? So if you're selling t-shirts for $10 a t-shirt and you sell 5 t-shirts, you've earned $50, right? That is what your revenue is. So in general, the formula for revenue is the number of items. So that would be like 50 t-shirts times the price per item. So that seems pretty basic, and it is if you're just looking at a fixed price and a fixed number of items that you're selling. But in these questions, we're looking at how revenue can change as the price that you're selling at and the amount that you sell changes. So in general, if you make something more and more and more expensive, less and less and less people will purchase it. If you make something less expensive, more people will purchase it. So this relationship goes back and forth, but there is always, if you look at the numbers, amount or a price that will maximize revenue. So the combination of the price that you're at and the number of people that will purchase your product at that price or your service will give you the most amount of revenue possible. And that's what businesses are looking for. Okay, so that is the concept here. And I'll be also graphing these situations on GeoGebra to show you visually why a parabola makes sense within the context. So let's go to this first example about Alex and his snowboard, it's her, female Alex, and her snowboard rental business. So Alex runs a snowboard rental business and she charges $12 per snowboard and averages 36 rentals per day. So this is kind of what she does right now. She discovers that for each 50-cent decrease in price, so every time the price goes down by 50 cents, her business rents out 2 additional snowboards. So this is the changes happening. So every time the price goes down by 50 cents, 2 more snowboards are rented. Awesome. So what price can Alex use to maximize her revenue? So before we actually get to the formal mathematical solution, let's actually just think about what's going on here. So you can either do this on the side or on a separate piece of paper, just make a little corner of some room. So right now, her current revenue is, so it's 36 snowboards times $12 per snowboard. So right now she's getting $432 per day. So that's pretty good. Now, what about if there is one change? So notice that one change means a 50% decrease in price and 2 additional snowboards. So then her revenue, she'll have 38 snowboards and $11.50 per snowboard. So notice that the price is going down, but the number of snowboards is going up. So if you do 38 times 1150, you get 437. So notice that that is a better revenue than her current situation. So great. So then she might think, oh, if I can do that, I should just make a ton of changes. What if she thinks about going all the way to making 10 changes? So 10 changes at 50 cents and at 2 more snowboards per change. So if she changes 10 times and there's 2 additional snowboards rented per change, then that's a total of 20 more snowboards. So now we're at 56 snowboards, and 10 50-cent price decreases is an equivalent of $5. So now her price is $7 instead of the original 12. So 56 times 7, whoa, that is only 392. So that is a lower revenue than our original. So that's not good. So somewhere between just changing it once and changing it 10 times, there must be a number of changes that gives me the maximum revenue. So one way of doing this would be just to, trying it out and doing a table of values, doing guess and check. And that works for these questions that have exact solutions. But when you get to grade 11, the questions will be a lot more complicated with decimal solutions. And so a table of values really won't help you. You'll need to do the actual quadratic method. So that's what I'm going to show you now. So the key here is that we start with our revenue equation. So let's start with the English sentence. So in this case, our revenue is determined by the number of rentals times the cost per rental or the price per rental. Okay, so we have right now 36 rentals plus 2 per price change. And then our cost is $12, but it's going to go down 50 cents per price change. So notice these are kind of like Englishy sentences, just to kind of wrap your head around the situation. So let's actually introduce a variable now and create a quadratic equation. So we're going to say let x represent the number of 50-cent price changes. So how many times we change that price. So now our revenue is equal to, okay, so the number of rentals is currently 36, and we're increasing it by 2 every time we have an X. So 2 rentals per price changes. Our cost is $12, but we're decreasing it by 50 cents per price change. Notice that this is a formula for revenue, and it is quadratic. It's a factored form of a quadratic equation. So at this point, you have 2 options. You can either find the 2 x-intercepts, or you can FOIL to put it into standard form and use x equals negative b over 2a. In this first example, I will do finding the zeros. In example 2, I'll do the other method just to show you that they both work. Okay, so to find the zeros, we set this 36 plus 2x to 0. So 2x equals negative 36. So x is equal to negative 18. So let's think about what this means. This is the number of rentals. So if x is negative 18, so we have actually 18 price increases, we would have nobody renting anymore because there's 2 additional rentals per price change. So if we had 18 price increases, that would result in nobody renting any more boards anymore. So we would have no more revenue because nobody would be there. Alternatively, you can take the price changes, or how the price changes, and set it equal to 0. So here we get negative 50 cents equals negative 12. So x is equal to 24. So x equals 24 represents if there were 24 price decreases, we would be at $0. So we also wouldn't be making any money. Think about it. If we're at $12 to start and it's 50 cents per decrease, then 24 50-cent decreases would be $12. So 12 minus 12 is 12. All of a sudden the snowboards are free and revenue is nothing. So the optimal revenue is going to be at the number of price changes exactly halfway between these two scenarios, or the X value of the vertex. So that is 3. So notice that our X is 3. That does not mean that our new price is 3. That means that that is the number of price changes that we should have. So therefore, 3 price changes gives, so that's 3 times 50 cents per price change. So we are going to decrease the price by $1.50. So in fact, even better than saying price changes would be to say price decreases. So therefore, our new price that will maximize revenue is $12 minus $1.50. So $10.50. So what price can Alex maximize her revenue? $10.50. Now, if you wanted to throw a little sprinkle on there, you could put X equals 3 back into your revenue equation and find out that the revenue at this price would be $441. So she would be making $9 more than she is right now per day, which adds up. So let's take a look at this on GeoGebra to make a bit more sense. So I'll just put Y equals, if it lets me, there we go. Y equals, and I can just put the factored equation right in there. So 36 plus 2x, and then do times, what was it? 12 minus 0.5, oops, 12 minus 0.5x. So notice you're like, it doesn't show up. Well, that's just because it's way the heck up here. Okay, so here we have to find our vertex. Okay, remember that the y-axis in this case represents revenue, and we know we're up in the 400s, so it's actually way up here. So in order to see this better, I'm going to change the axes to just show maybe minus 10 up to positive 50. Sorry, I'm just having some trouble here. Okay. So we just want our X min to be minus 5, let's say. Actually, we'll do minus 20 to positive 30. And our Y min can be negative 5. We don't really need but below 0. And our max can be 500. Okay. So here we can see pretty much the whole parabola. All right, so here are zeros. So again, that represents when we have no revenue whatsoever. So at 18, that would be price increases. Since X represents the number of price decreases, a negative X value means price increases. So at that much we're making no money. And at 24 price decreases, we're making no money. So this is when we're charging $0. This is when it's so expensive, nobody wants to buy it. So our revenue increases and increases and increases. Now, the y-axis represents when there are no price changes at all. So that's our current scenario. At no price changes, her revenue is $432. So as the price decreases, the number of price increases, our revenue goes up until at 3 price changes, we hit a maximum revenue of $441. But then the price is getting, even though there's more people renting snowboards, the price per snowboard is getting lower. So your overall revenue goes back down again. So that's why a quadratic curve makes sense to model this scenario. Okay, so let's do one more example here. So I encourage you to try this one on your own if you want to. It's a little bit different because we're dealing with price increases, and then the number of riders is decreasing. So if you'd like, you can pause it and try it, but I'll go through it a bit more quickly than the last example. So in this case, our revenue is determined by the number of people riding a bus times the price of a bus ticket. So right now you can see that we're at 12,000 people a day, $8 a ticket. So you could calculate the current revenue if you wanted. So we're going to say, let X represent the number of, in this case, it talks about 25-cent price increases. So the number of 25-cent price increases. So let's create our equation then. So the revenue is, so right now we're at 12,000 people, but we're going to decrease by 600 for every price increase. And our price is $8, but it's going to increase by 25 cents every time we increase the price. So in this example, I'll FOIL this. So when you FOIL this and collect like terms, you get a negative 150x squared minus 1,800 x plus 96,000. Okay, remember we want to maximize revenue, so we want the vertex of the revenue equation. That's so important to understand. Maximize revenue means vertex of the revenue equation. So the x value of the vertex is negative b, so 1,800 divided by 2a, so 2 times negative 150. So this gives me an x value of negative 6. So you might think you made a mistake because you got a negative number, but negative 6 price increases just means 6 price decreases. So it does have validity within this scenario. So negative 6 increases of 25 cents means 6 decreases of 25 cents. Therefore, we're going to go up $1.50. So therefore, the new price should be 8 plus $1.50, so $9.50. Oh, wait, sorry. We're going to go down 150. I made a mistake. Down 150. So our price, so 8 is 8 minus $1.50. So $6.50. So if we decrease the price to $6.50 per ticket, we'll get so many more people. That is a way to maximize revenue. So that will be the correlation there. So you can also graph this on GeoGebra if you want to see what that looks like. But it also, for the same reason, creates a curve. And the vertex in this case would have, the x value of the vertex would be negative 6, and you can find the corresponding revenue. So I hope you liked that on revenue. I think it's a really neat application of quadratics and very, very applicable to everyday life. And you'll be seeing it again in grade 11. So thanks for watching. Hope you learned lots.